Today we're going to talk about the distance formula. This is section 3.4. And the first thing I want to do is just tell you where the formula came from, like why we use it. So let's say, for instance, that I wanted to find the distance from this point, which is -2, 1, to this point, which is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 4, 6. So if I had these points on a picture like I do, then finding the distance from here to here would be, if I use Pythagorean's theorem and treated this as a triangle, would be a squared plus b squared would give me c squared, right? So remember Pythagorean's theorem, a squared plus b squared equals c squared. C has to be my longest side, which would actually be the distance between those 2 points. So how would I find A? Well, A would be this distance, 1, 2, 3, 4, 5. It's how far up I had to go, right? So if A was 5, it would be 5 squared plus B is 1, 2, 3, 4, 5, 6, 6 squared. And if I wanted C, I could take the square root of both sides and I would get plain old C, right? Well, another way of writing this distance that I counted would be, for my Y, right, this is at 1, this is at the height 1, and this is at the height 6, right? So in other words, if I took this Y value 6, subtracted 1, I would get that height of 5. For my B, if I took my X value here at 4 and subtracted my X value at -2, 4 minus a -2 would give me the 6. So we're using Pythagorean theorem, but they've put it in formula form. So the formula then is this. Instead of using a C, they're going to use D. D is my distance, equals the square root of my, let's say I called this one point, my first point, my second point. So let's go x2 minus x1. In other words, my second x point, which was 4, minus my first x point, which was -2, gave me my 6 squared, right? And then I squared that, added it to the y2 minus y1 squared, and that's my answer. So it looks like a really big, horrible formula, but in fact, it's just a way of figuring out the distance that y travels, the distance that x travels, and because each of those are sides of a triangle, then I would square them and add them and get the square root in order to use Pythagorean's theorem. So that's the distance formula. Let's do a problem. Let's do problem number 1. So problem number 1, it wants me to find the distance between 2 points. And the 2 points are 3, 1 and 75, -20. So what I do is I label my points. Of course, they're ordered pairs, so it's always an xy, xy. If this is my first point, I'll put 1s there. This is my second point, I'll put 2s there. So I would then need to plug these into my formula. So D equals, and let's do the x2s first. So x2 minus x1, 75 minus 3 squared plus, how about the y's? -20 minus 1 squared, and that whole thing is under the square root. Then using your order of operations, 75 minus 3 is 72 squared plus -20 minus 1 is -21 squared. Notice I put the -21 in parentheses because when I square a negative, it becomes positive. But if I left that out of parentheses, it would have kept it negative and would have made your answer wrong. So if you want to just get into a good habit, just keep them in parentheses. Okay, I can do this on my calculator. 72 squared, get an answer. Negative 21 squared, get an answer. Add those together and then take the square root. And for this question, my answer ends up being 75. Let's look at question number 5. So there aren't a lot of questions in this homework, which is good because the problems are a little time consuming. And especially question 5, I think it's the most time consuming. They give you these vertices of a triangle. So we have 0, 0, 15, 8, and then 23, 23. And they want to know if it's isosceles. Well, the way you'd know if it was isosceles, let me plot these first. 0, 0. And let's see what would make that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so if these are each worth 2, then 15, 8 would put me at 2, 4, 6, 8, 10, 12, 14, 15, 2, 4, 6, 8. There's my 15, 8. My 23, 23 would be 16, 18, 20, 22, 23. So 20, 22, so here would be my other one, right? So if this is my triangle, they want to know if this is an isosceles triangle. Now, to the eye, it looks like it. Isosceles means that 2 of the sides are the same length. So this looks like it's the same length as that. But to be sure, what you would do is 23, 23. You would take the distance from 15, 8 to 23, 23 and see what that is, and then take the distance from 0, 0 to 15, 8 and see what that is. And if those two distances are the same, then you would say, yes, that is an isosceles triangle. So I just wanted to show you the setup. So it becomes 2 problems in one. So you're going to do the distance between these two and the distance between those two. And if they are the same, then you would say, yes, that is an isosceles triangle. Okay, let's look at problem number 6. I just want to set that up for you. So they give you this baseball field, and they ask you several questions about it. And it's really not that hard other than to get the coordinates of everything. So if they said that the Major League Baseball diamond is actually a square 90 feet on a side. So if it's 90 feet on a side, and let's say this is first base and this is third base, then this is second base, right? So home plate, the coordinates would be 0, 0. First base would be 90, 0. Second base would be 90, 90. Third place would be 0, 90. And then they may give you like an outfielder somewhere or whatever, and then they'll ask you to find appropriate distances based off of these positions. Okay, so I just want to help you get those labeled so that you can then work through the problems. And then finally, I want to talk about question 7. And again, the issue is labeling it. So mine says a lawyer drives from her home located 3 miles east and 11 miles north. So east would be this way, here's 3, and 11 north would be here. Of the town courthouse to her office located 7 miles west and 13 miles south. So 7 miles west would be 1, 2, 3, 4, 5, 6, 7, and 13 south would be like down here, right? Just remember that because you went west and south, these would be negative. So if I'm trying to find this distance from here all the way to here, then what's important is I enter the negatives into my formulas. So what would I do? I would label these x1, xy1s, xy2s, and then I would put them into my formula. So x2 is -7, and then -3, and I'm going to square that, plus y2 is negative 13 minus 11. I'm going to square that and then take the square root of that answer. Negative 7 minus 3 is negative 10 squared plus negative 13 minus 11 is negative 24 squared equals my distance. 10 squared is 100. 24 squared is, let's see, I'm not sure, I don't have a calculator on me. (24) squared is 576. If I add those two together, I get 676. Square root of 676 is 26. And that is my answer for that question. Okay, so hopefully that helps. You're really just doing this distance formula for all the questions in the homework. And I would just pay attention to keeping those parentheses because of this issue here, right? There's a difference between negative 10 squared, which means negative 10 times negative 10, which gives me positive 100, versus negative 10 squared, or even the mistake is we type it in like this to our calculator. That's telling the calculator that the negative is not affected by the square. 10 times 10 is 100, so it gives you a negative 100. So be careful, because you don't want to tell your calculator that. And that's it for this. I'll talk to you later.